Hello, boys and girls. Welcome back to another edition of Crush Lusher Television. All right, this lesson is on continuity, and there's not a lot of math you do with this. This is more conceptual. So I want you to write down the stuff that I ask you to write down, and then I want you to think about what everything means, okay? That's going to help you with the exit quiz as we go. All right, hope everyone's good, having a great weekend. All right, so today we're going to define the mathematical term continuous. What does continuous mean? But I'm not going to tell you what it means. You're going to tell me what it means. Well, let's see. So here on the left, we have continuous functions, and on the right, we have not continuous functions. So this function here is continuous. This function here is not. This parabola is continuous. This parabola is not. This function here is continuous, and this function is not. Now, I want you to write in your notes, continuous. I want you to write what you think the definition is right now. Pause the video. These are continuous, this is not. What makes something not continuous and what makes something continuous? Go ahead and do it. All right, great job. This is what it is. It's very simple. A function is continuous if you can draw it without picking up your pencil. Easy. Second, draw this whole thing. Ooh, don't pick up my pencil. See this parabola? I can draw it without picking up my pencil. See this line? I can draw it without picking up my pencil. See this function here? I got to pick up my pencil. That one too, that one too. So you can draw it without picking up your pencil, you're good. Okay. So most functions are continuous for most parts of their domains. Any point on a function at which a function is not continuous is called a discontinuity. So a discontinuity, write this down in your notes, is a point at which a function is not continuous. And there's 4 different types. Okay, so I want you to sketch these all in your notes. So I have the answers right here in front of us. I'm just going to talk through what the answers are of all 4 types. Okay. So the first one, 4 types. So the first one, you guys see this jump right there? Guess what? It's called a jump discontinuity. And it's at x equals 1, because that's where you got to pick up your pencil. You're drawing, oh, x equals 1, you got to pick it up, okay? So where is the function continuous? So down here, so anything between negative infinity on the x all the way until 1. Why do I put this bracket here? That means that it equals 1. So that bracket means equals, and this means not getting to, so not equals necessarily, because you can never get to infinity. That's just an idea, okay? And union, this means union, means together with. You can also be continuous when you start drawing from 1 until infinity, and 1 doesn't have a bracket, 1 just has a parenthesis because you're not actually getting to 1, okay? So next, here's the parabola we talked about before. This is called a removable discontinuity. So draw this picture, pause the video. This is a removable discontinuity. It's got a hole in it. So it goes by both names. And the hole is at x equals 3. That's where you got to pick up your pencil. So where is it continuous? From negative infinity, you're drawing until you get to x equals 3. With union, together with 3 all the way to infinity. If that's sort of confusing to you, this is what it means. So when x is less than 3, all that stuff, or when x is greater than 3, that's where it's continuous. Okay? Next. So the function is continuous on the intervals negative infinity to 2, or from 2 to positive infinity, or x is less than 2 and x is greater than 2. So write that down. And this is called an infinite discontinuity because the graph goes up forever to positive infinity on the left and then down forever to negative infinity on the right. So it's called an infinite discontinuity. This next one is not as common as it usually is, as the other ones. So the function is continuous on the interval. So 0, something's happening. So what happens is the function goes and it goes up and down, up and down, up and down, up and down a lot at 0. So it's called an oscillating discontinuity at x equals 0. So when x is less than 0, you have a continuous function you can draw without picking up your pencil. When x is greater than 0, you can draw the function without picking up your pencil. Okay? So, get that down. Pause the video if you need. Here you go. So, I'm not going to give away the answer to that just yet. We're going to try it on our own. Boom. Here it is. So, here's the example. First, I want you to identify what types of discontinuity we have. I just went over 4 of them. And where they are. I think I see a few. Where are they? Write it down and where they are, like x equals 7, x equals 9, x equals 2, x equals 0. Where are they? You get it? Let's see. Here we go. So at x equals 2, there is a removable discontinuity. There's a hole. And when x equals 4, you got a jump discontinuity right there. Hopefully you got that. Where is it continuous? From -2 with the brackets to 2. That's why you have to pick up your pencil at 2. And then from 2 to 4. And then from 4 to 8. That's where we have a continuous function. Let's try another, shall we? If you didn't get that one, that's okay. Boom. Ooh, look at this one. How many types of discontinuity do you see? Write them down, write them down, write them down, write them down. Pause the video if you need. I see a few. Let's see if you got it right. Boom. So at x equals -4, what is there? Oh, there's an infinite discontinuity. Bam. It goes up forever here on going towards the right, and it goes down forever. At x equals 1, there is a jump discontinuity. You're drawing. Oh, you gotta go up here. And then x equals 3, boom, there's a hole. That's a removable or hole discontinuity. Got it. And you are continuous from -4. X is less than -4. From -4 to 1, and from 1 to 3, and from 3 to infinity. Anything greater than 3. So that's where we are continuous. This is more important right now that you know this part, and you can identify these discontinuities, okay? Now, next time we're going to get together, and I'm going to take away the graph. The octopus is back. It's going to take away the graph. But right now, I just want you working on this, okay? So, your exit quiz, we're going to work on that stuff next time. Bam, here it is. So you have 4 questions, 9, 10, 11, and 12. Determine if each function is continuous. So write continuous or not continuous. If the function is not continuous, find the x-axis location of any discontinuities and classify each discontinuity as infinite or removable. So you have to say this has a infinite discontinuity at x equals this, or a removable discontinuity at x equals that, or it is continuous. So you gotta do 9, 10, 11, and 12. Good luck. Nice job, everybody. Take care. Hopefully you had a great weekend.